It's me, dudieboy! Today I'm going to show you two different storage systems with different automatic sorting mechanisms and different item transportation methods. And I'll list off the types of farms you might use them for. All I ask in return is that if you find this video useful, please click the like button to help me show it to more people on YouTube. Both of these storage systems use tileable, accessible storage silos. By accessible, I mean a column of double chests turned sideways with all the chests on one side and hoppers in the back. This way, all the chests are accessible from this side. Get it? The bottom hoppers will drain the upper hoppers before the items can go into the chest, so that the first chest to fill up will be this bottom one close to our feet. How high can we build this silo? Well, that depends on how high up we can reach on a column in front of us, and the answer is 7 blocks up. But although we can reach the 7th chest here, notice that we can only access it via a very small area at the bottom. I mean, we have to stop and aim up to find that small area, and that really slows us down. Actually, I was reaching it pretty well. To make sure all the chests are accessible quickly, only build your storage silos 6 chests high. Now we're going to add the mechanism that will sort what items are stored in this silo. This means that this entire column of double chests will fill up with one type of item or block. Collect the building materials that are in my hotbar, then move to the back of your accessible silo and place a line of jack-o'-lanterns out from this top hopper. Then place 3 jack-o'-lanterns below those, offset by 1. Place a final jack-o'-lantern under the middle of this row and knock out the center. Now on top, place a redstone comparator facing away from the top hopper, and then shift-click to place a hopper going into this comparator. Cover the 3 jack-o'-lanterns behind the comparator with redstone dust. Place a redstone repeater in this space pointing into this jack-o'-lantern, and then place a redstone torch on the inside of this jack-o'-lantern. This is the Impulse SV tileable sorting circuit, named after the YouTuber from Herbertcraft who created it. This works by transmitting a signal from this hopper all the way back here, powering up this block, activating this repeater, which powers this block, and deactivates this redstone torch, which unpowers this first block, unlocking this top hopper to allow items through from above. The signal only becomes strong enough to unlock the top hopper when more than 45 items are present in the sorting hopper. So we'll use this top hopper as the sorting mechanism. It's pointed sideways so that this hopper doesn't automatically drain its items into the hopper below. Only the hopper below can pull items from the hopper above, but not when it's locked. To sort a single type of stackable item into this accessible storage silo, we'll fill the back 4 spaces in this hopper with stackable items of one kind and then place 41 items in the first slot. To prove how this works, I'm actually going to place 45 items into the first slot, and you'll see that the system allows 4 items to drain into the storage silo, and then it locks again. A couple of notes before I move on. You're probably wondering why jack-o'-lanterns, and the answer is that the jack-o'-lanterns are a light-emitting block, usually available early game and cheap, that allow you to place redstone dust on top of them. Whenever redstone items or dust power on, the game has to recalculate the light in the surrounding area, and this can actually trigger some lag, which can especially affect a server. The jack-o'-lanterns raise the light to the max so the game doesn't try to recalculate the light around the redstone, which reduces lag. Another note, this sorting system is best used for items that stack up to 64. This system will not sort non-stackable items such as armor, weapons and tools, filled buckets, and potions. Also, this sorter is not ideal for items that only stack to 16, such as ender pearls. Note that when I drop 16 ender pearls into the first slot, only 6 go through. This means that this hopper can only grab 6 more ender pearls before becoming full, meaning the next ender pearl that comes through immediately will not be sorted into this storage silo. Other items that only stack to 16 include snowballs, empty buckets, eggs, signs, honey bottles, and banners. And finally, use an anvil to rename the items used to fill these other slots as a safety against an item of that type accidentally getting sorted into the silo. Because if for some reason a stick were to come through the system, it will pass through this top hopper and could mess up this storage silo and your entire sorting system. Rename the item to something other than sticks so that the regular sticks won't stack up with these anymore. Remember that an entire stack of 64 items can be renamed on an anvil for only 1 XP level, so rename all the space fillers in one go. To sort the output of a farm, we can tile this storage system like I have here with silos side by side. Then we can fill the first hopper with the first bulk item, and then the second with the second item that the farm produces, and then the third with the third bulk item that the farm produces. At the request of one of my commenters, I'm setting up this system to sort and store the output of a farm similar to the double mob spawner XP grinder that I built recently in my hardcore series. Because the system must store the items dropped by zombies and skeletons, I have created 3 bulk sorting silos for arrows, bones, and rotten flesh. Because such a farm would potentially also output tons of randomly enchanted bows, armor pieces, carrots, potatoes, and even iron ingots, we need at least one column, if not more, of unsorted storage here at the end. Because these items would be unsorted in the chests, I'm going to add a connected storage silo here at the end. To build this, raise a column of chests directly up the middle, and then start placing alternating chests from the bottom, one in front and one in back, all the way up. Then place hoppers alternating on each side to fill the gaps. At the top, place another hopper into the top of the chest. In a connected storage silo, the storage chests are not all very accessible from the front. However, the benefit of this system is that if I take items from the bottom chest, the hoppers drain the upper chests down into the bottom chest to fill the gap. To connect these to the farm, we simply place a hopper pointing down into this last hopper, then run a line of hoppers all connecting into that hopper back to the start of the farm. I would then connect this hopper line to the farm, which in this example would be the hopper that the mobs stand on when I kill them. Because the farm in question provides a fairly slow and steady output of mobs, this method of item transport should be fine. I'll be sure to build this storage system under my double spawner XP grinder before my next hardcore episode. However, if the farm kills the mobs more efficiently, then there is a need for faster item transport. Because hoppers only transport items one at a time, a system like this would become clogged up if connected to a highly efficient guardian farm or a piglin bartering farm, and possibly break down with more items overflowing and not being sorted correctly. Water streams transport items more quickly than hoppers to the sorting system. However, there is a danger in using the regular Impulse SV sorting circuit because it only allows the top hopper to pick up 19 items from the water stream above it. In the case of some guardian farms, this might not be enough space, and some items might pass up the hopper. In this case, we'll need an alternative sorting system that allows for fewer sorting items in the sorting hopper. I've already set up a new accessible storage silo to show you how to build this sorting system. Grab the materials you see in my hotbar and move behind the top hopper. Run a line of 4 jack-o'-lanterns out from this hopper. Then under that, start 1 row back and run another line of 4 jack-o'-lanterns under that, then 2 below the center of that, then knock out these 2 in the center. Like before, place a comparator behind the top hopper facing away, then shift-click to run a hopper into that comparator. Then cover the 4 jack-o'-lanterns behind it with redstone dust. Put your 2 repeaters inside this space facing front, and then your redstone torch behind this front jack-o'-lantern, and you're all done. This system essentially transmits the redstone signal the same way as Impulse SV system, but requires a greater signal strength to unlock the top hopper to allow items through. Now we're going to fill the sorting hopper with one item that we want to sort by, which for a guardian farm is going to be a prismarine shard, and then 3 stackable renamed items in the middle slots, and finally, a non-stackable item. If you've got to craft the item, wooden shovels are probably cheapest. There are now 5 more silos, just like the first, tiled in together, and we've set up the sorting system so that we have 2 silos for prismarine shards, 2 silos for prismarine crystals, and 2 silos for raw cod, which are the items that you would get from a guardian farm. For a system using water stream item transportation, we need at least 2 silos to catch each type of fast-moving item. We are now going to build glass walls to either side of the sorting hoppers and run them both all the way down to the end and come out 1 more and put walls around it. This is the system complete, but to test this we need to put another glass in front and extend walls all the way around these. Then we're going to fiddle around with observers a bit until we get a dropper at the end powered by an observer clock. Break the back observer to turn it off a moment, then cover these top 2 spaces with more glass, and throw a water bucket underneath. Notice that the water flows out to the end of the hoppers. We want it like this to test it. We filled the dropper with 3 stacks of every type of item that is going to go into it to test the sorting. And when we add the observer back to the end, the dropper starts spitting out items. We're testing this system by 2 criteria. Do any items flow past all of the hoppers and off the edge here? And do all the items sort correctly? We're almost done, I think. And now that we are done, we can see that none of the items have slipped out of here. None of them have fallen off the edge. The hoppers picked them all up. And if we check the chests, we can see that everything's sorted correctly. This system is built to handle an even harder test with a faster dropper collect, so I strongly encourage you to try that on your own. However, if you go AFK at a well-built Guardian farm for an hour, you would still fill this little system to overflowing. So what I've built here off camera is a storage system with a wall of storage for each item type, with the water stream flowing back to the start just in case items still make it past all the hoppers. This now provides 4 silos for each type of item from a Guardian farm, which should be plenty of storage to allow you to go AFK at an overworld Guardian farm for an hour or even overnight perhaps. To keep the items flowing fast, we're using packed ice blocks in combination with top half slabs to keep the items moving around the track. One thing you want to avoid in setting this up is dumping your water buckets directly on top of any of the sorting hoppers, because if a water source block is there, it creates a possibility of items getting stuck in the little depression in the top of this hopper. So that's it. 2 automatic sorting storage systems with 2 different types of item transport systems to handle 2 different speeds of item input. If you enjoyed this video and want to see more, please click the like button to show this to more people on YouTube. If I get 100 likes on this video, I'll make another about automatic sorting systems in the Nether, shulker box storage systems that store millions of items, and more. Thanks for watching and have a great day.